Then this is already done, so let's start. For the people who don't know me, who am I? My name is Moises Macero Garcia. I'm based in Malaga, the south of Spain. I've been working in engineering and software architecture for more than 20 years. Time flies, actually. Applied a lot of technical knowledge, but in these 20 years, I learned that the most important skills are the socio-technical ones, because most of the problems with software are typically not technical, but how people communicate and how people interact with each other. What I do, I give trainings to people, but now I'm also trying to train AI agents so I can put my knowledge in kind of virtual avatars and you can use them. It's of course not replacing me, but you can get something out of there. I've tried a lot of different practices around AI augmented software architecture, and it's not that the thing can do the entire process, but it can help a lot by, for example, creating diagrams as code and this kind of things, as we will cover later. I do consultancy. I also give workshops, either package or customized, and I also do technical writing. It's that makes me also I think a non very standard technical person, that I actually enjoy writing technical documentation. So my journey with AI has been more intense since I quit my last job, and then I've been since March working more than 8 hours a day, I would say, with AI and doing a lot of experiments. I had been in touch before that, but it has been in the last few months where I learned all I know now. As I told you, I started applying architecture principles to AI development to see how that works. So I took a different approach to what was maybe misunderstood at the beginning as vibe coding. I have transitioned from being quite skeptical to being quite convinced that the future of the software industry will use AI, of course, with a few disclaimers, as we will see later. As the magic number, and this is a wild estimation that I've experienced myself by building things on my own, but also discussing with other people, I would say that you can gain this 4 times the productivity. I built a few things. You can check them online. Of course, it's not the same as building the things in an organization, but I've also checked with real teams that are using AI on how they're using it. My positioning might not be as vital as other people that you see on LinkedIn, like saying, hey, you can fire 200 people tomorrow or something like that. That makes, sadly, that I'm not as vital as other people, but I'm trying to be like one of the voices that say, hey, it is useful, but it also comes with some traps that you have to avoid. So that's what this session I will try to make it about. So the agenda of today is this session is divided into 4 parts. The first is a bit of a recap on how AI has disrupted the software industry. So we will see AI tools, some examples that are going across the 7 phases of the software development lifecycle. And I will give you an example of how you can outsource some part of the work to AI, just to feed the hype a bit, just for fun. Then on the part 2 is hype versus reality. So what I learned that AI can do and what is suitable for versus what it actually does, right? And then we will also see like coverage, that is not like a binary thing, and also control and how you can apply control to these different stages. Then the part 3 is about how to be in control and what that means. And the part 4 is entering into the practical details on how to do a structured AI coding. So you will learn what I mean by that. And of course, these days, naming is volatile. You can call it the structured AI coding. It's not exactly specs driven, but it's heavily influenced by that. So yeah, you will see what I mean by that. So let's start with the part one, the AI disruption. Just to provide the context, I'm using the 7 phases of software development as in the kind of old-fashioned SDLC framework, where you have software development lifecycle divided into steps. And that might sound a bit waterfall, but you can implement this in many with different methodologies. So it doesn't need to be waterfall, right? But this has a bit of a stigma that it's an old-fashioned thing. So you have planning, where you have the ideas and you're trying to make a plan out of that, divide it into steps, probably with different scope, and you have some goals, and then you start looking into requirements. In the analysis stage, you go a bit deeper into the requirements. You can have customer interviews. You can review data that you collected to see how to implement the different steps that you need to implement. Then in the part 3 is where you try to connect the business and functional part of your goals into a software implementation. So that means software architecture, but that can also mean UI design, UX, and more like translating the business requirements into a model, right? Then once you have a model, you start coding. And then as you can see here, this is like, you can divide it into 7 stages, but probably you're already thinking, yeah, I've been in companies where there is no design or no one releases. Yeah, that's fine. It's normal. That happens. Some people go directly from planning to coding. I mean, if you're in a startup or you are a solo developer, you can do that. Even big companies, sometimes they, depending on the business case, they can also skip some parts of this. Then there is testing, that you could also argue, well, you can do testing before coding. Okay, then you're doing TDD. Deployment, so you have tested it on a test environment, and then you put it on production, which means that other people can access this software. And they start trying it out, and they start using it, and then you have to do maintenance, which is that you will have bugs, you will need to fix stuff, and even you will want to improve the system and add new features or whatever. So this is a very simple framework, and it's useful to take it as a baseline to discuss about AI tools, because it's very clear. And again, it's not about doing this in a waterfall way, because you could do planning, but to do planning, you need to do some analysis and design and even deployment, right? Because you maybe want to deploy a prototype before doing your entire planning. So it's just a way to divide the lifecycle. Then we have some examples of AI tools that are available at each phase, and they don't position themselves as focusing on one specific stage of the software development lifecycle, but it's just to have a mental map of how you can use it across the spectrum. So these are just examples, right? So for planning, you could be tempted to go to ChatGPT and start using it as a sparring partner to see, okay, how can I plan this? Or can you help me refine this business case, or find competitors, or see what features I should prioritize? You can also use Notion AI. You can use Atlassian AI agent, which is called Robo, which sounds really bad in Spanish anyways. And for analysis, you can use Figma AI, you can use Miro AI, you can use Lovable, that you can also use for planning and implementation as well. In design, you can use this triplet, which is Claude Code, Cursor, Codex, or any other AI coding agent to build some sort of specifications. If you want to follow a more structured approach, you can give it a try to Amazon Keto, which is based on specs driven. There is also GitHub Specs Kit, which is something similar, where you are somehow encouraged or even forced to write the specifications before you are passing this to AI agents for coding it. Then in coding, you can use again the AI coding agent. Copilot, meaning like the autocomplete feature that many people have been using already for a while, that you press tab and then you get code, but it's more like in your function or a snippet. In testing, you can use the same tools as well, which might be quite useful for creating test cases. In deployment, you can give permission to these tools to start working in a more agentic way and then running scripts and doing things for you. It's a bit risky if you are not using it in a very constrained way, but hey, you can do that. There is also an MCP for AWS, which I wouldn't recommend using it in if it's not read-only, but hey, if you feel brave, you can also having a conversation with your agent to start deploying things and checking things on AWS. And there is a similar thing for Vercel that you can use. On the maintenance side, we have the two major providers of operational platforms, like Datadog has Bits AI, Dynatrace has Davis AI, and Elasticsearch, they have an AI assistant as well. And there are a lot of major players entering AI, as you can imagine, and then there are new tools popping up every week or every day, actually, on this field. So this is a way to visualize it, but you could also say, well, it's if we put the 7 things on a horizontal line, you can go for the first row, like you can combine multiple tools across your software development lifecycle, and that they are more specialized on doing specific things, which can be good. You can use another category of tools that you can see as feeding the hype, or magical tools like Lovable, where you give them a prompt and then you have an application. There is Lovable, there is Bolt. There are a few of them that are promising that. Then there are the AI coding agents, like in the non-structured version, which would be, again, Claude Code, Cursor, Codex, these tools that you can, they are quite flexible, and then you can use them across the spectrum. And there is Kiro or SpexKit, where you can use and similar coverage, but in this case, it's covering a bit more of the analysis because it allows you to go a bit deeper into the specs and the plan. So the promise of many of these tools, and then we enter the binary argument here, is that some of these stages you could outsource completely to AI. And then this is where the misunderstandings start popping up, because it's like, okay, so it seems that if I give a prompt, then I'm outsourcing the entire design and coding, and maybe even deployment, and then I have a web page working in minutes. But in this example, you would be doing planning and analysis, and then testing and deployment and maintenance. But this specific example sounds a bit risky, right? Because if you outsource design and coding, how are you going to do maintenance on a black box? It's if you don't know what was coded. So that's a big challenge. So you could be wondering, okay, how many of these phases of software development lifecycle can I outsource to AI agents or tools? And then I play with something a bit just for fun, which is, what if I wouldn't have even a plan, and then I prompt to AI, I want to make money with something, just give me something. And then to make it not that open, I said, hey, do something in the energy sector that makes me, that I can make money with. And believe it or not, this worked after after some time. And I will show you what I got from this. So I didn't pass any detailed requirements whatsoever. I just passed that prompt, and then I just I got the popcorn, and then I saw the tool making and has its best all the promises, right? So I used Claude Code for that, and I asked Claude Code to, hey, make me money. If you, let's try to zoom in a bit, because otherwise you won't see anything. But it's basically, this is Visual Studio Code, just to give you a quick overview. On the right side, there is the Claude Code interface where I can just chat with the agent. On the left side, we have the project structure, which is only the README file. And then the README file on the right side, you see the editor. And the editor of the README file just says, create a software application that they can make money with, something energy sector related. And then there is another editor open where I got the plan from Claude Code that is the same as it's proposing in the chat. And it's basically saying that, okay, let's build a SolarROI Pro. The business model is that it's a SaaS for solar installers. They pay me for me to send them leads, and then I collect the leads by providing the leads a solar calculator that they can check how much money they will save by inputting their address and then connecting to a US API that it seems that it's existing. Anyways, that was like the plan from Claude Code. I, of course, auto-accept it and in the sense of, okay, create all these things automatically, and then I just click buttons here and there. And then minutes later, I got an app built. So you can see here, it was really happy, Claude Code, and then it was promising me that I would make $10K a month. Backend, front-end, business documentation, the revenue model documented in a Markdown file. So yeah, this is the hype on the top, right? With all the README file, I got backend, I got front-end, I got a lot of things. Of course, Claude Code promised me that it was working, but then when I started it didn't work. But since I'm a developer myself, I could instruct Claude Code to fix it without much interaction, actually. So that went also quite well. And then, as I told you, it was promising me $10K a month. I didn't deploy it yet, so I cannot say if it gave me $10K a month or not. Maybe I will try. I don't know. Just to show that this can cover a lot of the software development lifecycle, whenever Claude Code was asking me to do something, I would say, no, do it yourself. And because I have Claude Code connected to my Bash and other tools, then it could run commands to build, to deploy, and to open even the browser and show me the thing. And then the product was running, and these are two screenshots of how it worked. So there is a solar calculator that I could click on. Then there is the CTA for solar installers to subscribe to my service. So I got a fully functional calculator promising that it will also save money for users I can make money with, and then also solar installers will make money. So it's a win-win-win business. And yeah, it's a bit scary, right? Because it's like, okay, now we are in the time where it actually took me 30 minutes to have this thing working. And this is crazy. Just the fact that I can do this, it means that there is a disruption. I mean, we can like it or not, what was produced, but this is disrupting the industry if I can do that kind of thing that quickly. And then what happens here is that every week, depending on the week, actually, depending on the stories that are shared, you can see developers like panicking or maybe becoming AI haters or Luddites and no, this is a bubble, it will explode, it's not affecting me or something. We will come back to this, right? But there is a kind of a wave, like every week is different. And yeah, and it's quite hard to get common sense in between all the noise, I would say. So the hype around AI tools is coming because there are thousands. If you can just try to follow, if you are not doing it already, Y Combinator on LinkedIn, and then I think every day there is a funny video about something that it is an AI startup that you pass a prompt and then it does something, which is marvelous, but also it is to be proven the quality of that thing if it's not a prototype. And then all the people are thinking, is this a bubble? Is it a good time to start adopting it or not? Because there is a lot of noise. Am I being sold the snake oil? Is this people trying to take advantage of me? So my stake here is fight the hype with knowledge. So I'm sharing my experiences, but you can also say maybe I'm biased and I'm trying to sell you something. Yeah, of course, maybe I'm trying to sell you something, but it's on your side to actually judge it and see if it's valuable or not for you. But you need to take the time. So the takeaway from this first part is that the disruption already happened. It's already there. There are a lot of tools being built. There are people doing things that are actually helpful. Maybe some people are overusing it or underusing it, but we shouldn't deny that it's disrupting the way we do software. So yeah, the way I like to approach it is just being pragmatic and saying what it can be helpful for you. And maybe before moving on, because then I will start with the part 2. If you have any questions, just feel free to, after each part, I can take some questions if you want. Otherwise, you can always ask at the end. So the part 2, hype versus reality. So the dream scenario of AI building software is that it's really a black box, but it's a black box that can self-heal somehow. And then I explain it with this story, like if we could build a black box of software that is fixing itself, then there are no war rooms anymore. There are no incidents. You don't need to be on call anymore, because if there is a bug, there will be an AI agent that will talk some gibberish with the AI agent that wrote the code, and then it will fix this on their own, right? Just by them trying to figure this out while you are enjoying somewhere else. So machines fixing machines, and then self-healing. But are we there yet? No, actually, we aren't there yet. So if I would claim that what I built is production ready, and Claude Code was promising me a few times after I asked that the Solaroid was production ready, that would be feeding the hype. There are two major walls here when you are building software with AI. The first one is the software evolution. So everything you do after building the first MVP or iteration, you don't understand the code structure. So AI agents will be, you will rely on AI agents, or you need to navigate the spaghetti code. If you rely on AI agents, there is this thing called context. At the moment that you make your application bigger and bigger, they will start collapsing their context, and then they are all the time trying to free up the context and then starting back again, and they lose all the memory. They start becoming very inconsistent, and they start doing things like it's called AI slop, even more than they can do in the first iteration. And yeah, you need to review the spaghetti code or even your AI agent, which is even more risky. And then there will be a point where you are thinking, wow, this would be actually much faster if I fix this, if I would have implemented this, but maybe that's not the case. And then on the other side, you have the failures that you get on production. So you cannot fix them yourself if you don't know the code. You have an AI dependency. When it works, because it can actually fix bugs, I've seen it doing it. Many times it's adding more technical debt because it's trying to introduce a workaround instead of fixing it the proper way. So there is, again, there can be a lot of AI slop there. So I cannot call my SolarAI application production ready, because then I would be selling snake oil as well. So where is the AI bubble? Well, of course, there are people who are investing money in these AI startups and products, and probably they want money in return at some point, or they are very optimistic. I would say marketing is making all this look more capable than it actually is. And it's also painting it more fun than it actually is if you want to get productive results. So AI and the models are good at when they have been trained with a lot of examples about a given solution. So, for example, if you try to make an AI coding agent come up with an example to specify or to draw diagrams or to create a documentation, and you don't say what you want to produce, I've always got the authentication example. They always go to the user authentication because probably these models have been trained with a lot of user authentication data. And this is good and bad. It's actually good because if you want to implement user authentication, then you don't need to write all the boilerplate yourself. If there is a model that can write this for you in whatever programming language, and it's going to be 80% accurate, and you are just reviewing it. But then these models are also good at having a task that has as small a scope as possible. If you give a very complex problem, and that complex problem is not a very common problem, then the results are going to be much worse. So what these AI coding agents are doing are kind of copy pasting with some logic behind it, because this is at the end some pattern matching. So it's like I would go to a Stack Overflow in the good old days, and then I start copy pasting code to create my application, and then of course I would have exactly the same problems that I would have with the Stack Overflow. It's completely inconsistent. What these models are not that good at, even though they are trying to let's say simulate it, or they are becoming a bit better with time, but not that good, is at reasoning, at trying to make sense out of a big problem. Same as system design. So if you pass a business problem and you say, okay, let's model a system that solve this business problem. Again, if it's not very well known, it's not a good idea to delegate this task to an AI model. So I've already touched a bit on this. So when you have a tool that is doing a copy paste with some smart, let's say, adapting it to your code base, what you have is that a lot of inconsistency. Is that you start giving instructions, and then the next time you give more instructions, but it's not exactly what you wanted to build, and then eventually you get a system that is not maintainable. So navigating a bit into what is a possible structure, and many people are realizing this, is that it is, as we have been doing all the time as well in software design, you try to split a big problem, a complex problem, into a set of smaller problems, and then you define the interfaces between them, right? So this is the bread and butter of software architecture, but then this is a level farther because you're doing this for AI. You give constraints and preferences. So if you say, hey, I will use functional programming in Java, and these are my rules, you pass them these rules in a written text. So they will try to respect them most of the time. And then you start getting consistency. You can also manage the context by, instead of passing a big problem and say, hey, build this in one iteration, you try to split this problem into iterations, which is, again, something that we have been doing or trying to do in the best way possible in software development. So it's the same patterns that apply to software design and architecture and mapping business with software, but this time working with AI agents. And then the result is that you get a decently created code. And by decently, you will see what I mean. So if we split a big problem into many small problems, that would mean that this picture, just to give an example, On the picture number 1, you have someone who is just giving a vague prompt, not writing, not taking care of decomposition, and then you get a big complex system as a result that might be working as Solaroid, but then you don't know how to actually modify or evolve it. In the number 2, we have someone who is investing more time and giving prompts and the tech stack and the preferences, and then they have even split the system into components, which makes that each component has a lower complexity. Now, in an ideal situation, if you take this to the future, let's say, if one of these components that you decompose is failing, or you don't like the AI solution that has been built, you could replace that box by another box that can be written also by an AI agent in 30 minutes. And then you are not even fixing the problem. You're just replacing one of these little boxes by some other box that you don't even know the code, that is taking the same inputs and doing the same outputs, as long as it's properly specified, right? Because otherwise this approach wouldn't work. But anyways, in the high level, the principles are the same. You are just decomposing your system so problems are smaller. So what you get with this is that you will lose the bright side of having low effort, but then in exchange, you get better consistency, because if you're not passing guidelines, then you don't get any consistency at all. You get a lot of complexity. And the only thing you have to do is to make an investment at the beginning in writing all these things. The problem is that this, of course, I guess that what's happening as well is that when you create an AI agent that is capable of coding an entire software solution, it is very boring that you start talking about software architecture, because software architecture has always been boring for a lot of people. So imagine that now we say that people need to do software architecture for AI agents, and they start like, I don't want to write markdown documents for a machine. Why is not just creating my solution? And that's it. And that's how we behave as humans, right? Is the minimum effort possible. But in this case, I can tell you that you get much better results when you make that investment. So the reality check, now pass it.
Moises, I have a question. Can you go back to the previous one? At any given time, point in time, are you checking the code is producing on any of the cases, first one or the second one?
If I have made experiments about this,
No,
or
I mean in your iterations. I guess in the first approach, you are just getting the big black box and you are not checking the code. But in the second one, that you have a smaller piece of codes, I don't know if you are checking the code or you are just fine with whatever you get.
It's a good question. In this example that I'm giving, but I didn't get into that detail because it's I will enter into that later as well. But the small robot icons that you see on the components, that means that I'm not interacting. So that's more like written by AI, and I'm not reviewing the code. So it could be like if I have a problem later on production, I will need to dive into the problem or use another AI agent and take the risk of, okay, I don't know what's going to be produced. But the outcome, when you do proper decomposition, the outcome of these components, also for a person, the cognitive load is much lower, because then you can try to dive into the problem and then, okay, maybe there are like 20 classes or something like that in the project. Then you can navigate through that much faster than if you take 2,000 classes at a time. So yeah, in this example, it's like that. But then we will see the control levels, and then you will see that it's not black and white. It can be any shade of gray. Thank you.
Okay, thank you.
So in reality, in my experience, and also as you can see by analyzing what people who are not trying to become viral are saying, is that we need to be in control for the most important things that humans can do, which is reasoning, just providing why we want to build something and how we want to build it, and providing a structure as well, or decomposing problems into smaller problems. And ideally, you get to a situation where the control is adjustable. So for some situations, you want to be in control and you want to give very detailed structure. And for some other situations, you can just autopilot the entire thing and leave the AI agent do their black boxes. So if we look at this new dimension of control, then we could plot a few of these tool examples into this graph, which on the horizontal side, we have the coverage. So we have the same as before, but this time being more to the right means that they cover more of the spectrum. And on the vertical axis, we have how much control they allow the human to have. It's not what you can adjust them to be, but how they are positioning. And then, of course, this is on my experience, right? So you can have a different view, but this is just a way to visualize as well the tools. So in this case, these specialized frameworks they provide you with the less coverage of the entire software development lifecycle, but you have a lot of control. So you can actually interact as much as you can. You can do everything on your own, or you can delegate some of the things to the AI. Then to give the counterexample, there is Lovable or Bolt, where they have been made so you don't need to control anything. You just pass a prompt and then you get the entire thing done. And even you can deploy them. And then there are some things that are in between. And actually, they could move in the spectrum in this graph up and down or left or right, which are Keto and SpexKit, which is this specs-driven based way of developing with AI agents. And in general, what I'm calling a structured AI coding, that it doesn't mean exactly the same as what Keto and SpexKit are doing, but this is something that you can build yourself with prompts and context. And you can do that with these tools, or you can do it with Claude Code and other tools. And then we have these multi-purpose AI coding tools. And in general, if we would go to their parent companies, we could say that Claude Code or Anthropic, and then OpenAI with Cursor, with Codex, what they are doing these days, they are extending more and more to the things that you can do with them. And that's why some people are calling them, every time they release a new feature, they say that feature is an AI startup killer, because there were some AI startups that were filling some gaps around what these tools could do and their models. But now these companies are entering into the vertical businesses and offering the entire thing on their own, which is actually eating some of the other tools. Because, for example, with Claude Code, I have a slide about that later. Claude Code is called Claude Code, but you can do a lot of non-code things with Claude Code. So it's and it's not the same as using Claude in the desktop. But yeah, I will cover that later. Daniel.
Hey, Marcia, just a question, because a lot of those tools, I get the impression they are built on other models, right? Like Lovable, etc.
Yeah.
Can they be interchanged in the sense, like how dependent are they on like one provider, and basically if that provider ever decides, or if that model decides to change something, like you're just screwed? Or can they actually sort of switch? Now we want to use OpenAI's model, now we want to use DeepSeek or whatever.
Yeah, exactly. So that's why they are eating as well their their competitors, right? Because if, let's say that with Claude Code, I will try to how can I stop that animation? If they are using a different model, what they are providing at some of these tools is a kind of facade on top of a model, right? It's like a wrapper. But then the funny thing is that if Anthropic decides to build a Lovable kind of thing by going into that vertical, you could say that you can pass a picture and a prompt to Claude Code, and then Claude Code is building the entire thing and deploying it to a specific platform as a service provider. And they could do that tomorrow, and then who knows what happens with these tools. So yeah, it's they have the advantage that they don't depend on the model, so they can interchange their models at any time. But at the same time, they are helping the other companies to train their models, and these companies can eat their business model. So yeah, I don't know if that answers your question.
Yeah, so there are, like, they could plug in a different model relatively easily. Like, it's not that they are completely dependent on one flavor, so to speak.
Now, most of them, they are not depending on a specific, but they have big partnerships. So it would be really weird if they suddenly change to another provider, I would say. So then we enter the 3 levels of control that you can apply with AI. And there is Autopilot, which means that you just pass a prompt and that you get your thing done. There is a Copilot. Well, first there is the pilot, which is that you are in full control, and then you might be using AI, but just as an assistant, that it doesn't have that much participation. And then you can go into a co-piloting mode where you are passing some details to the AI agent, and then at some point you switch the autopilot at a different granular level, and then you can build your things with the AI agent without looking into what is being built. And then, of course, there are different degrees of doing that as well. And the problem with Copilot is that it's a word that it has been already quite overloaded with different tool names, but you get the concept. Is how much you want to be in control in the spectrum. So then the 3 paths that you have, which are this autopilot, pilot, or copilot, the thing is that they are good depending on your business case. If you're doing prototypes or you don't care about the internals of something because you're building a demo or something like that, then you can go fully autopilot. And that's good for that, but it's bad for production systems because they are really hard to maintain. If you are in a very regulated or you need to build something that is extremely secure and audited, I wouldn't recommend to go for a lot of AI controlling the thing, because it's because it actually requires a human. You cannot sue an AI for making security mistakes. Probably someone will be responsible for that. And then there is the co-piloting approach with a specs-driven and more patterns of agent orchestration and defining patterns. So here the trick is choosing the level of control based on your context. And there is no best tool. But if you work in an organization and you go to that organization with this plan, like, hey, there are like 7 phases in the software development lifecycle, or however you want to model your process, and there are 3 levels of control. Okay, good luck. Let's start using AI. Let's start adopting AI. That's not very clear what you want to mean by that. And then you could enter into something that has happened in the software industry a few times with different technologies. And I'm using the example of the microservices effect. So when microservices became popular, everybody wanted to move their monolithic application, even if they didn't have a monolithic application, into microservices. But then in many companies, there was no clear strategy to do that. And some people even jump on the hype of, okay, let's go for polyglot microservices, and then every team can do their own programming language, and this kind of, I'm not in favor of that. It's quite chaotic, and it creates a lot of anarchy at the end. And now it can happen the same thing. If there is no clear AI strategy, people can use whatever tools they want and whatever control level. Maybe some people are delegating writing emails to their colleagues, or they are not using AI at all because they are quite skeptical. So I would say that for organizations, it's important to have some structure, because otherwise what you get is examples of people creating functional requirements, for example, writing a Jira ticket with fully by AI, right? Just passing a small prompt, or entire code bases that they go to production, and then there are new LinkedIn titles like I fix AI slop for companies or something like that. So these people are becoming a trend these days. And then this creates a lot of frustration for engineers, but actually for everybody, but especially engineers that are becoming very strong position against AI. So they are becoming AI haters, which is not good, I think, because there is value in using AI. And then it's also causing inefficiencies in the sense that either you are over-reliant on AI and then you lose control, or you are underusing AI for things that you could be using and then save time and money. And if every team is using it in a different way, then you are missing opportunities of reusing prompts and knowledge that happens across teams. So what I propose to organizations is that they create an AI strategy that clearly says how you want to adopt it, in which stages, and you co-create it internally with a few representatives. And this could have an owner within the organization, and ideally you can have a recurrent meeting every week, 2 weeks, and then with your plan on how you want to experiment with it, is it valuable or not, and then move it forward or rolling back. But just trying to create your own AI strategy. And it can be as simple as having a table. It's a spreadsheet. You don't need fancy stuff. And you just put here your business line that can be a given product that maybe needs to be very stable because it has millions of users. And then you will also have demos or innovation projects or another product that doesn't need that much attention, let's say. And then for every product, you can list use cases like we are refining functional requirements, or we are coding a new API integration with a third party, or we are building a pilot, or whatever. And then you choose your level of control in these 3 classifications, like piloting, copiloting, or autopilot. If you want to fine grain, you can give it a score as well. Like I'm using here 0 to 5, meaning 0, you are not using AI, and 5, you are going wild about it. And then which tool are you going to use it? And ideally on the examples side, you put how you are using it. And then after experimenting, you can say, hey, I found very useful to do code reviewing with Quado, and we are using it with these instructions that are in this markdown, and let's unify this across teams that are in this product, or things like that. If you need help, especially on the inspiration of which use cases you can use, I'm building a new website with a lot of things that I've been trying out in these 7 phases of the development cycles. Everything that is there for all the capabilities you can check. I will be building prompts and instructions, and understanding the control levels. You can take a lot of information from there. And it's actually everything that is there that is not packed and bundled together is just for free. It's a beta, so it's you need to be patient for the entire content to be available there. So for the part number 2, the takeaway is that the way to control or let's say the way to navigate the hype is by having control on the things that are important. So the question is not whether you will be replaced by an AI agent, but how you can accelerate some part of your life cycle by using AI, and then stay in control and not lose your business to AI. And you asked a couple of questions during this part, but if you have more questions, feel free. Yeah.
Yeah, I have two questions. Like, one is maybe a little bit about like what level of seniority do you need? You've mentioned like you need to provide the guidelines, so you need to provide sort of the structure. Obviously, there's been a lot of talk like, oh, it's going to replace all junior engineers. Like, how do you look at that? Like, do you need like a senior enough person who has a good idea about, you know, architecture and guidelines on a team to be able to guide this, or can you just make do with some, you know, a basic team of a couple of interns basically, and just, you know, have a bare minimum of guidelines, and it will still work out?
Yeah, it's a good question. I think that there are like, these are two different skills, but so on one hand, there is the seniority of the person who knows the domain and who knows the system, right? And that could be like the content, let's say. But then there is another skill, which is how to dump that information into documentation. And this has been always a powerful skill. So how to make it in a way that other people understand it. So you are writing documentation. Not many technical people like writing documentation or creating diagrams or making visuals. So if you do these kind of things, you are helping seniors and juniors. And a junior developer, if they have the right skills, only by getting to know the domain and the content, they can also do this. They can also write good specs for AI. So I see that as two different skills, let's say. And then what I see as well, and that is a spoiler on the next part, is that people who know a lot about technical content but are not good at writing down how the thing works or describing what needs to be done, they will be forced to do this more and more, and then pushed away from focusing on the code and then doing more specification, which is good for everybody because it's good for AI, but it's also good for people. So yeah, answering your question, I don't think that you can replace junior developers, because junior developers, they still have the skills that human have that AI doesn't have, which is reasoning and splitting things into chunks and this kind of things.
Yeah, thanks. And maybe my other question, speaking about control, do you have any thoughts about like cost control? I have the feeling that a lot of the models are moving away from sort of an unlimited, you know, do whatever you want, towards, you know, like capping or limiting your tokens or charging by the token. Is that might be more relevant in the future, I guess.
Yeah, exactly. But the probably what they will start doing is exactly like that. So first they are trying to capture us by giving us unlimited, and then I'm paying $200 a month to Claude, and then I'm doing a lot of things every day, and probably burning way more dollars to Anthropic than what I pay. And the moment they start charging me for the real stuff, then maybe I will think it twice before sending prompts or not. But if you are working on something where you see value and you're not just playing around with it, in the long run, you will see the benefit. The problem is that at first, that could be a very heavy barrier for entry for a lot of organizations, because in the first month or couple of months, they will see like they are wasting money, because the first sessions that you have with these AI agents, they are not going to be productive. They are going to be quite costly for the organization. You need to wait until you get that return of investment, at least 1 or 2 months. So I think that in the future, either AI convinces everybody that is valuable, or there will be this barrier for the skeptical people that say, okay, it's better not to pay that much for this because I don't think that this can make a developer 4 times as productive. But if imagine that we prove that this 4 times is a multiplier of 4, it must be very expensive to actually not being worth the money, right? Because if you are making a person 4 times productive, that's a lot of money.
Although I can also imagine that there might be certain tasks that are like more suited or less suited, that you can burn a lot of money for little result, or like that might be an optimization at some point. Just like with AWS or whatever, you can burn thousands of dollars by not optimizing your setup and just going with the flow.
Yeah, exactly. And there are people who are sharing a lot of advice on that, just sharing how you can save money by reducing the context and managing the tokens that you're using and not doing this. So it's like do's and don'ts. But I don't think that has that much relevance right now, because there are many people who are using it in an unlimited way. But those good practices will become more relevant with time.
You could in the future run a local version of the AI on premise, and only if it can't answer it or if the answer is not good enough.
Exactly.
Paid AI.
Yeah, that would be a nice one as well. So you can run your own model if it's doable, which seems that will be the case. And then if you're using it a lot, then you can save a lot of money. So yeah, that's a good observation. Okay, if there are no more questions, let's go to the part 3, being in control. So I have this picture here to show a bit the what I've been hinting in the first 2 parts. There are like people working with people and people working with machines, right? People working with AI agents. And if this is like a map of a classic organization, typically you have some people at the top that they create the vision, the business vision, the roadmap, the goals, which targets we have for this quarter. And then on the technical side, we have people who are trying to split the system into different domains or different functionalities or sub-products. And then they create a strategy, some architecture, the technical standards, the guidelines, an AI strategy as well. This could be like appointed people, or it could be like a collective decision, right? That you implement somehow a decentralized way of making these decisions. But in any case, there are like top-level decisions that apply to a given system. And then what happens in every organization that wants to scale is that we apply the classic that has been working for centuries, the divide and conquer, right? So you say, okay, if I want to scale this, then I create multiple teams working on different parts of the system. And you can split your system horizontally, vertically, diagonally, it doesn't matter, but you say, I will split it using technical components, and then every team takes care of certain components. So you can split it based on domains, or you can split it based on lines of business or functionalities. And then people are behind all these decisions, right? So there are people who are thinking how to split the system and map this system to the business. And this is the Conway's law, and it will apply here and whatever. But there is reasoning behind all these decisions. And then in every team, they typically have either components or functionalities, different ones, and they can decide as well using their reasoning. Now in the world of AI agents, they can decide how much they use AI for every division that they have internally, for every component, for every functionality. Maybe in one component they are using it only for a few integrations, but not for other ones. So they are deciding that in that sense. And then it doesn't matter if the organization is having a commanding style, very waterfall, or they are the most modern organization that are flat and taking decisions as a group. It doesn't matter. These patterns, they apply all the time, right? So they are like, typically there are like different divisions, and then people can be floating or not, but this is the way that people approach splitting a system. And then with AI, when I am talking about control, what I mean is what you see there in the magnifier glass and the box in the corner. The person becomes a commander, whatever approach is happening in the organization, that doesn't matter, but you don't typically treat AI as your colleagues and start writing like, hey, let's make this decision together. What do you think about this? I mean, you can do that as an sparring partner. So then you get inspired and you see, okay, maybe that was a good idea. But eventually you are going to be in control of the decision and what you need to be doing. So that's what the control and everything that will apply here in this part and the next part. When I'm talking about micromanaging AI agents or orchestrating AI agents or passing them a structure, it doesn't mean that we are creating markdown files with the architecture at the top level and then using that for the entire organization. You could very well not document the architecture maybe at the top level and then do it for the AI at the scope that you need to do, right? So that's it's useful at that level of interaction. And of course, I have an opinion as well on how useful that is for the organization, but that's not, let's say, not in the scope of this session today. But of course, it's useful to have these artifacts as well flying across the organization and having your vision documented, your functional flows, your architecture as well. But again, I'm talking about that specific scope where a person in a team or a group of 2 people, they are interacting with an AI agent to build something. And then the control, where it matters the most, is in the stages where reasoning and structure is dominating the most, right? So it's in the planning, in analysis, and design. And then a big disclaimer here is that the control is also important in the other stages, but as long as you have included the specs that are good enough on how to maintain the system, on how to deploy the system, on how to test, on how to code it, then you can be more close to an autopilot style with the AI agents at some point. So one thing that happens here on the side of the requirements is that, this is becoming trendy. Now people are writing full specifications, user journeys as text. And yeah, that is great, right? When I see that, I almost want to cry, because they are sharing all these AI prompts that they are passing to the machines. And there are many developers like me that we are thinking, wow, if only I would have received that documentation at some point, what a beautiful code I would have created, right? Not the AI. So there has been a long time of using things like agile or other excuses to say that, no, we don't need to write that documentation. And now they are trending again. So why is this happening again, right? Is it the hype? Is it the snake oil sellers? Well, in part it is, but I believe it is for a different reason. First is that people who are doing this, they get faster feedback. So it's not the same saying something really vague to a team and then waiting a week and then getting something that, okay, this is not what I wanted. And people are reasoning and filling in the gaps, than doing this with an AI agent that will create so much garbage in 5 minutes that you will see, oh, wow, I'm not really explaining myself. Let's do it a bit better. And then in 1 hour, after iterating with the AI many times, you get to 2 pages of documentation. That could be either in a prompt, like in a conversation, or you could be dumping this into a markdown file and then reiterating with the chat to say, go again to the markdown and do this again. So faster feedback is quite powerful here. And then people are realizing that they need more details. And also for many years, we have confused autonomy and ownership of teams with mind reading, in the sense that you give a vague instruction, hey, we need to do this, and then you think that no, they should do this because they are a team that is self-autonomous. Okay, they are self-autonomous, but maybe you are not explaining yourself in the goals and in the functional workflows that this needs to have. So that's also a problem. Also because we were coming from very old-fashioned waterfall, where we couldn't see the product running until there were like 2 years building something. Of course, that's also not good, but there is a sweet spot in between, right? It's not that you don't need to write any requirements. And one thing that you can see to validate what I'm saying is that Lovable, which is like the major player in you give a prompt and then you get your app, they have in a corner of their documentation, it's not that visible, they have something that they call the Lovable prompting guide, where they are describing how to properly specify a task, basically, but for an AI. But if you read it, you can see that it's the same as you would do for a person. You define what you want to achieve, you specify the technical stack, which is maybe somebody else would doing that in the past. You elaborate on the features, you give the context, the constraints, all these things that are important, right? But now you're doing it for AI. And then I played the game of, okay, if I change some words actually on how people are doing prompt engineering, or how people would write requirements, you can just replace some words and it makes perfect sense. It's what you would do to a person. It's like you explain what you want to achieve, the requirements, the goals, and the context or whatever. So defining requirements, how you can define requirements for an AI, it changes a bit because you could use visuals, but then the visuals that you do, if you focus, for example, on user journeys, which are, in my experience, really powerful with AI agents, you explain what are the actors in your system, what are they doing, and what they do what happens next. So it's like an actor model, right? And then you start chaining actions, and then at some point, that actor wants to achieve something, and then they will get it by following that flow, right? For example, buying a product or something like that. Those are your goals, and then you map that with metrics. You can write all these things as text. You can have all these things in Figma, for example, or something like that, and then use one of the tools that are already available, like Figma AI or Figma, how is it called? Figma to Code or something like that, where you connect an MCP to Figma from your Claude Code, and then you map your visual into text, because that text will be what your AI agent can use as the source of truth to build the product. The formats that works the best, as I'm saying, text, if you want a bit of formatting to make it easy to read for you as well, the best is use Markdown. And there are new tools that are emerging for you to actually do it visually, and then, let's say, building a user journey that you can actually feed to the AI agent directly. So it's not only for humans. So this is some high level. I will deep dive into a bit more into this in the part 4. But yeah, it's never too late to start defining requirements properly, and especially at that level inside the team where you actually want to leverage AI to build your features or your functionalities. For the technical side, there is another thing that is coming back from the dead, and that is UML. I think I've been using UML in the last 7-8 months more than in my entire career. It's crazy, because I realized that AI agents are so good at, on one hand, helping me by just having a conversation with the AI agent to visualize what I want to accomplish, because you can have UML as text with Mermaid or Plant UML, and you can have sequence flows, component diagrams, entity relationship models. Those are so powerful to visualize what you want to accomplish. And then you can use that as well as a source of truth for your AI agents. So again, plain text, markdown documentation. You can play a bit with images, but they don't work that well. It's much better when you do that with markdown, at least in my experience, and at least at this time. Maybe in 3 months, the AI agents are perfectly reading a UML from a picture. And then, of course, on the technical side, but also this is a shared responsibility, there is a bridge between how to map the user journey that you are specifying on the functional side to technical components, on which actions of that user journey are encapsulated into what component in your technical vision. So you can have you want to model billing on one domain, and then for billing, you want to encapsulate these 3 actions that are part of this user journey, this kind of things, right? So you need a way to map that. I created a framework that is also open for everybody to be inspired if you want to have a look at this. It's influenced by well-known frameworks and tools like the actor model, or just having user journeys, or a C4 diagram where you can encapsulate, let's say, smaller technical components or even functions in this case. So you can give it a try. I have a video there. There is also a web page. I will share all this material with you tomorrow. So yeah, this is what I'm using to build my applications, because this is text-based, and then you can build tables that are mapping how these actions are mapping to technical components. And then if you are doing this the right way, you can basically use that as the source of truth and produce code for those flows. So the real disruption here, I think that AI is bringing, and yeah, is that before AI, we were spending a lot of time writing the code, and I've written there a 20% in thinking design, but in some cases, I think it was much lower. But we are shifting it to more thinking and designing in the terms of writing things in a markdown, perhaps, and less of writing code. So that means that for technical people, developers are becoming more like architects, in the sense that they are designing the code and then something else is building the code in small pieces, ideally. So they are mapping the business to high-level system design, but also to low-level system design, and it's more staring at the screen and less typing like a psycho, which means that, yeah, still there are for some people, this will be a very hard transition, I think. For product managers, they need to enter a bit more. They don't need to write UML, let's say, but what we need to make work much better is that there are more collaboration in between the person who is writing the user journey and the person who is mapping it to technical component, and they get together and they get assisted by an AI to visualize, to measure what they want to build. And then once they have a common view, aligned business and technical, then they can start, the technical person can start implementing this in code. For prototyping, that's also very powerful, because yeah, basically what a product person can do now is they can write a prototype, show it to customers, and then get feedback much faster than before, where sometimes you needed some code to make a feature work. It wasn't as simple as a clickable demo. So yeah, this is where I think that the industry is going. And then you can thrive by staying in control, and then you will not become an AI hater. And it's about mastering the fundamentals. So this is the kind of combining the 3 parts that we have been covering so far. So first, understanding in which parts of the development lifecycle from the early beginning you need to master tools like writing user journeys or defining metrics in a way that can be understood by people and AI agents. So those are like where you can control. Then you start experimenting, you learn about what they are capable of, and then you choose what to do with them. So that would be your strategy that you can evolve over time, and then you can find your sweet spot. And then if you decide to go into, let's give it a try, to co-piloting and passing specifications and see if this works, then define that with the structure. You can use plain text, markdown, UML, user journeys, actor-based modeling, and you can get AI to help you build the visuals while you are in the driver's seat. So yeah, the control is the combination of where you are applying it, how much, and whether you define it with a structure. So the takeaway from this third part is that we are transitioning from coding to thinking. And I think it's if we reduce the problems to a level where you already have in your mind as a technical person, you know exactly how the code would look like, and you are only, let's say, 3 hours away typing code from solving it, then that's the kind of thing that you can get with AI in 5 minutes. So that's the thing. So then you are pushing yourself a bit up in the flow just to think, reason, design, and you can do a lot of things in less time. Any further questions about this part?
Yeah, just one question. You mentioned you're talking about like software architects, software engineers becoming more like architects, more thinking. I know it's too early to say, but just wondering if you have any thoughts. But like, do your coding skills atrophy at some point? Like, say in 5 to 10 years, like you can't judge anymore how the code should look, or you can't fix that annoying bug that shows up, or is it?
Yes.
Or will it be like we'll have a JVM situation where you don't need to worry about memory allocation, and some low-level system will fix that for you?
Yeah, if I can do a wild prediction on that,
Yeah.
that is actually what I think it will happen. That, for example, I can give you, and this is being recorded, but I don't care anyway. I can give you a personal experience. My coding skills in Java have already started at lowering, because I'm not typing anymore as much as I was doing in this period of almost 1 year. So then it's not that for any little thing I'm just delegating it to AI, but if I'm more like mapping concepts and less thinking on how to solve this with this algorithm or this other. So in this case, I think it is degrading actually. And there are some people who are a bit imagining where this will go, because now we are using programming languages, but at some point, people are saying and making wild guesses, like, okay, the programming language will be the best programming language for AI, which might not be the ones that we are using for people. So why would AI code in Java or Python? Maybe they come up with something that is much more efficient for them. And it's like, yeah, I always use the example of Google making this bot for you calling the hairdresser to get an appointment, and then the hairdresser having another AI agent to take your appointment and write it down. And I always make the same analogy, like, why are they speaking in English or in Spanish or whatever? Yeah, at some point, these two agents will start making beeps, right? They will call each other, they will find the best way to organize a schedule. Why they would start if nobody is listening? So the programming language, I think, is going to be the same. You are, as you are saying, your programming skills, you get an atrophy on that, but that should happen only when the AI agents are capable of fixing or self-healing things on their own. Because otherwise, if that happens before, then we have a big problem, because then we will have a lot of technical debt that nobody is capable of fixing on production. And these people on LinkedIn selling themselves as fixing the AI technical debt, they will become rich at some point, right? Because they will get so much work.
You also mentioned the example of a memory in Java, right? So 90% of the time that's true until you get into performance issues, and then you do need to understand how it works.
Yeah, exactly. And they are not very good at this point at trying to optimize code because they are not good at reasoning. So they will come up with some examples from the internet. Thomas.
Yeah, so I like your example, and I like, hey, we use UML and then we can, build something beautiful greenfield. But the comment that really triggered in my heart is the part where you said, oh, now finally people are writing down things in requirements. The reality is that most of our coding is in existing systems more than 10 years old, where I don't have an actor model flow, I don't have a UML, I don't have anything. So you really convinced me for my next greenfield project. Could you elaborate a little bit how you would see this for any 10-year-old application?
Yes, I can. Let's see if I can convince you for that as well. So what I've been trying is I have a side project on my own that I created a few years ago. It was a SonarQube application to introduce gamification or whatever so that is legacy, actually. It is a mid-size project. And then what I could try is like, okay, how can I apply this after the fact? And you can actually do that, but it requires a lot of time. And again, it requires someone who is capable of navigating the code and mapping it by doing reverse engineering into specifications for the AI agents, that the next time that you're going to evolve that code base, that is perfectly documented where to find what. And even if you are not using the actor model in the code, that's not that relevant. The important part is that you document exactly who are the people interacting with the system, what are they doing, and where you can find these functions that these people are doing. And if you are doing a typical three-layer architecture with big business services and whatnot, if you do reverse engineering helped by an AI assistant and paying a lot of tokens because you will get reset every 5 minutes, you can write down a good markdown saying, hey, if you need to modify this functionality, go to this part of the code, this other package, and this other package. And you can get good results with that. I've been playing around with that, and you can get good results. But in that case, the effort is different. It's not that you are modeling from scratch. It's that you need to reverse engineer the entire thing and then build the baseline for the next iteration. But that works quite well, especially if you include in the markdown as well. Whenever you are touching this functionality, do never scan this package and this package and this package, and be very explicit about that, because some parts of the code are choking the AI agent, right? The moment that it starts navigating into that. So yeah, but it's I don't know if I convinced you, but it's possible to work with legacy with this approach as well.
I'm very happy you tried it. Thank you for sharing it.
Yeah, no worries. More questions? No? Then we can jump into the last part, which is mastering structured AI coding. I already introduced the main principles, but let's see with a bit of recap what is happening as well in the most specific area of coding with AI. So we were coming from no AI at all to autocomplete with things like GitHub Copilot. That I would say that acceptance is quite high, that there are not many GitHub Copilot haters. There are a few, but okay, it's not as much as at a different level. Then we started with the entire thing of vibe coding, and that introduced a lot of noise and hype about, yeah, you can do a prompt and then you can get everything working. Of course, people wanted to sell their tools and whatnot. And this is what produced most of the haters, because people started trying this and then they would see that they cannot maintain the code that is doing this. You ask AI to create a REST API, for example, to cover certain functionality, and scope creep is massive. You will get twice the functionality that you ask, and you don't know exactly why. And yeah, it's frustrating, even with the new models as well. So people are trying to, on the tool providers, they are trying to fix this. And you see how Claude Code is these days making a lot of questions. And they even tried out some prompt-based interview or something like that, where you ask a Claude Code to do something and it comes with 5 or 6 questions about how to proceed. And but back in the time, people were actually losing or wasting time on doing this. So the idea is that you get to a stage where you can actually get productivity with some structured way of working, as we will see. So the danger is in the stage 3, and this is what is preventing many people from entering into the trying things with AI. So the 3 fundamentals of structured AI coding is task-driven, which means that this is same as you would do with people, right? So you are splitting a big problem into different iterations, the minimal thing that you can build, the next thing, and you are keeping this as code in your repository. Next to your code, you have the task specifications. Specs-driven, which is, that probably you have heard about this, and also about task-driven, because there are tools that are also enforcing these things. And this is mapping the functional requirements to software design. You can use UML, text, or whatever. But then passing these instructions to the AI agents. And the third pillar that is very helpful is using specialized agents, which means that not only you are splitting your system into, let's say, time iterations and spatial iterations, but also each of these blocks and pieces, they could be tackled by agents that are tailored to their needs. Like you could have backend specific agents that are good at writing documentation, and then you manage the context much better than doing everything with the same agents. And this is what I believe that can give you the 4 multiplier of productivity, if not more. Task-driven development is having a conversation with the AI agent to refine requirements. So you are using it as a sparring, but you document the task not in the conversation, but in a file. So there are people who are suggesting to use a folder within the repository, which is called AI docs. I think it's a good idea. So then you could use AI docs/tasks. There are tools that are driving this process for you, like Amazon Kiro, that you can create a task. And I think that it's in Specs Kit, you can do that as well. But you don't need to use these tools to do this, because you can actually have an agent that is helping you create this structure as well, or you can do it manually. But the idea is that instead of keeping your information and your smart refinement in the conversation, you keep it in a markdown, which can be version control. Otherwise, the context gets lost, the conversation is lost, and then the agent doesn't know exactly what you're talking about because it was not persisted. You can integrate with MCP servers. Like imagine you are in your Claude Code and you say, hey, read the Jira ticket XX123, and then get the requirements from there, and let's document those requirements in the Markdown, because I'm going to start implementing that. So you don't need to rewrite things that are already written, because there are so many MCP connections that you can have, that probably there is one for your needs if you already have this task documented somewhere. But instead of using all the time the MCP connection, I still recommend to make a copy on the repository, because then in the task you can put more things that are not in the Jira ticket. So this gives you the ability that the context is never lost, because you can start a new session and point the agent to the task. You have traceability for you and the team, and you can work as a team in a much better way, because you can start doing some stuff and then someone else can continue that later. And then the problems are exactly the opposite. On the specs-driven development, the core principles are that you are mapping the functional requirements to technical design, and then you are, if you have already your task specified, you can attach to that task how you want to solve it. So there are two levels for this specs-driven. On one side, you have the master specs, let's say, and those would be these ones, the global architecture, the guidelines, and the technical stack that you're putting in a markdown or somewhere in your agents .md file or in the repository. You are documenting this. And those specs that are for the task itself, like imagine you have a system that is, I don't know, an e-commerce, just to make it simple. And then you want to introduce a new feature. Your master specs are reflecting the latest snapshot of the system. So how it behaves until you are adding an increment. And then when you have a task, you can add some technical specs to the task to say what you want to accomplish with that, how you want to solve it. And probably whenever you finish that task, you are changing the master specs because that task that you're doing, it will have an impact on the master specs. But there is so much of this work that you can co-pilot with an AI agent that it's not that much overload. Then why is it important? Because when you are going to produce a lot of code, it's much easier to agree on an entity model and sequence flows than trying to read after the fact 50 different classes produced by the AI agent. It's day and night, the experience. On one hand, you are driving the process, you are telling AI what needs to be implemented and relation between them. And on the other side, you are completely overwhelmed by the amount of code. And then you end up giving up on quality and just accepting things because you are just completely overwhelmed. And you say, okay, whatever, if this works, it's fine, let's go for it. And it also prevents over-engineering because if AI is inventing something, you will spot it very quickly. Like, hey, why are you adding this to the entity model? I don't need this in the entity model. Just remove it. And then it's much more visual. So you go with the specs, you ideally produce diagrams or you do them both at the same time. And then from those, you produce the code. So ideally, again, if we look at the future, it would be really nice that in a project, you have your code and you have a sequence of tasks that you have been creating with the master specs, and everything is versioned in Git. And imagine you have one task with the specs, and then the final specs are committed right after that. And the same thing, you have a chain of this, and then you have the code. Ideally, you could remove entirely your code and say, I don't want to do this in Java. I want you to start again from the beginning, like a bit of event sourcing, right? I want you to start again from the beginning and then do this in Python. And then you go iteration by iteration, and you could replay the entire thing and see how the source of truth that are your specs and the tasks can produce the same system in a different programming language. That would be really powerful. I don't think it's technically possible right now. Probably you would get a very different result, even if you have good specs, because you still need the reviewing process. But that would be quite powerful. I think that we should move in that direction. Specialized agents, the core principles here is that you create kind of avatars in AI with different specializations and with different instructions. And this is also very helpful, not only for managing the tokens, but also for you, because you can have your own team. You can even assign names to that. That's what I do. And then you can have your own team of avatars that do the front end, the back end, the documentation, and they know your preferences because you wrote that in their instructions. Depending on the tool, you have to store them in a different place. For Claude Code is in that specific folder. Claude Code also supports now skills, which are kind of plugins where you can have agents, but you can also modify a bit the behavior of Claude Code by using hooks and other advanced features, which is quite powerful as well, especially for organizations where they want to have a very strict flow with AI agents. And you keep the context efficient because every agent, you can use it for the right job. Like if you are deploying something, you don't need the front-end specialist or something like that. So I already told you the advantages and example agents that you can use. You can use backend, frontend, DevOps. I also have one for DevOps. Is quite useful. And the documentation writer, for example, if you want to follow some standards, or if you want to say that you create an agent to document APIs with OpenAPI, and then you pass some standards that you want to respect on your APIs, that's also quite valuable. So those are the 3 pillars. And then let's say that the last part of this presentation is 10 tips that I have learned over time that are very helpful when working with AI-assisted development. And those are, well, I can just list them quickly because I can go through them one by one, but those are these 10. The first one is you can be skeptical, and it's always good to be skeptical and not trust either the hype or even what I'm telling you. Just go there, pay some credits, buy a subscription, and start trying yourself or in your organization. Don't be a Luddite and then just deny that this is happening, because I don't think that that will be helpful. This is a bit controversial, but this is something I've believed my entire life. The code is not your mode in the organization. It's not what makes you different or needs to be private, unless you have invented a very powerful algorithm that is making an optimal finding of the shortest route from A to B and nobody else has it. And then it's completely patented or whatever. Okay, in that case, it's fine. But in many organizations, the code is not your mode. So you can connect wherever you want. And then is Anthropic or OpenAI using your code to train their models? Yes, probably. Should you care? In my opinion, not that much, because unless you have that type of organization. But yeah, typically it's more about how you manage your business, your people, your culture, your value proposition, your partner, your customer relationships, sales people, everything else, right? Don't be cheap, especially at the beginning. Okay, you will pay a lot of money on AI. Yes, that's true. Are you getting value out of it at the beginning? No, probably no. But you have to wait a couple of months maybe. But if you end up with good productivity, and you can try it not by wild entering into AI, okay, each developer gets a license for unlimited credits. And maybe that's not a wise approach. Maybe it should be a step-by-step approach where people are experimenting with an AI strategy. Some assigned individuals are trying different things, giving feedback. You set up an AI community. This is much more efficient. It's better not to pay per credit, because then if people see like the money is going up, this feeling is quite bad, right? Like you are creating 2 classes and then you see like, oh, I spent $15. How is it possible? And then you feel bad about it and maybe you are giving up. So it's better not to see that. It's either you have a subscription, or it's better not to check how much is costing. Of course, someone has to check, but the person, the individual that is trying, it's really bad if you are checking the cost every 15 minutes, because that's not a good, it's not a good feedback. So yeah, my recommendation here is start small and scale when you prove the value and where is the value for you. Avoid the microservices effect. This is something that we covered already. Don't do anarchy and then everyone using their AI tools as they want and everybody purchasing licenses just to give it a try. It's better to share these things, like same as we are doing with the developer experience, sharing some libraries, some people, or say that you're using Kafka and that there are some common patterns. It is something similar. So there are things that you can share. And I gave you the example of Claude Code. You can even build artifacts to share them as a common library or a common artifact in your organization. So start small and take time to build your strategy again. For prototyping, let it go. Just whatever, you start being wild. And this is very good for innovation because it can take so less time to write a prototype with AI compared to what it would take to try to do it yourself. But then make clear the expectations, right? That prototype, and this is also something that we have been, that it has been a pain point for many years. A prototype is a prototype. If you want to use it for production, that's a different thing. You cannot convert a prototype into a production-ready application just taking what you have and then making a small increment, right? That's not how it works. Maybe you need to start over again. But as long as you have it and clear, it's so powerful making prototypes with this. You can use Claude Code, Codex, Lovable, Figma AI. There are many tools that are entering into this area of prototyping. Know your tools. So if you chose to use Codex or Claude Code or whatever, make sure that you have someone who can take time regularly to check the updates, because there are so many things popping up every 2 weeks, new features. Maybe there is something that can change and make a disruption in your process, like for good, let's say. And it would be really bad if you're missing it. So you can give it a try. So it's good to be up to date about this. Yeah, understand the potential risks, master the capabilities, and where to learn. Most likely in the official websites, there is already a lot of information. Otherwise, you can get someone who knows about it and then just have some consultancy. But in any case, something that is better to just follow LinkedIn viral thing, right? Just go to the official docs. Train domain-specific agents. So this is a bit different to using technical experts as agents. In this case, this is a bit extending it a bit farther, where you are telling an AI agent as well what is your domain and how you work with the different flows and functionalities. So you can do as well some PM, some product management sparring, and build user journeys or identify things that are wrongly mapped from technical to product. So that would be on the technical side, what we have been discussing, the high-level design architect. You can have the low-level design architect, and you can use it also for sparring, for road mapping, feature prioritization. Of course, here you are entering a risk area, but if you are all the time in control, it can give you some inspiration. Connect all the MCPs you can, of course, with as many as your policies are allowing, but it's so much powerful when you connect these things to the AI agents, because you can do a lot of things. You can query data from, or you can check the logs from your logging platform and then analyze patterns from Claude Code, or you can analyze your Jira tasks from the agent, Notion, Figma. You can do so many things. Typically, you Google your tool that you want to integrate plus MCP, and there is someone either in beta or already production ready. So yeah, you can do a lot of things with these connections. As I told you earlier, Claude Code is also Claude No Code, because you can use it for things that are not coding. For example, I use it for this presentation because this presentation is used with Slidev or Slidev, wherever it's pronounced. And this is making a presentation from code or from text. And then everything that is powered by text I can use the AI agent to model this, right? Which is quite cool. I prefer it over PowerPoint now. You can do diagrams, you can do documents, you can create documentation for a website, and you can, of course, create applications, but other things with Claude Code. And for these things, I would recommend to leverage specialized agents. Like I have an agent for building this presentation. I have an agent to research things on AI, and then each agent has different instructions. I could use Claude Desktop or ChatGPT, but something that I really like about tools like Codex or Claude Code is that you can have this memory in your repository in the folder where you can store all these artifacts. And in the desktop versions, you can do similar things, but they are not as handy in my experience. For boring reports and repeatable tasks, you can, again, let the AI agents go wild, especially if these reports are boring because they are coming from compliance and nobody will read them anyway, which is sad, but happens many times. And then for these kind of things, you can just be inspired by what the AI agents are doing. And then you can also use them for repeatable process. So say that you go to a repository and you're upgrading the latest JavaScript library, which has breaking changes, and you are the first one doing it, and you are using an AI agent to help you document or make the changes. After you have done that, ask the AI agent to document a step-by-step process to repeat that, so someone else can use that knowledge on their repository to go through the same steps. It's not going to be perfect, but it can save a lot of time. It's the same as writing a README file for another person, right? But in this case, you're involving an AI agent. Leverage Git to make code disposable. So commit your tasks, your specs all the time, very often. And then it's you can always discard all the code. I do that all the time. And then you start over again, because sometimes you get like a bad session with an AI agent. Somehow the context gets polluted with something. I don't know what happens, but then that specific session, it only creates garbage and really bad things. So you close that, you start over again, and then you point to your task and your specs, and you continue from there. So yeah, you can do that in a branch, do that frequently, like same good practices that you would do for Git in general. Because AI has no real memory because it loses context, even though this is improving over time, you get a lot of value from having this in your repository. So the takeaway for the last part is that, yeah, try to master a structure, practice with it. Maybe you find better ways to do this, or maybe you love any tool that is already available, like a SpexKit, or give it a try to Amazon Keto or any other, because maybe while I was doing this presentation, there are 2 or 3 more frameworks for doing this. Follow those principles or the recommendations of keeping control of reasoning and using specialized agents, tasks, specs. And it is important, build a strategy. Don't fall into the trap of anarchy. So the future is now, which sounds very dogmatic. But a quick recap: as we went through the AI disruption, we saw how the hype is actually hype because there is a reality behind it, and it's better to keep control. We saw how to remain in control and having a proper strategy, deciding by yourself what to do and how, and some tools to master this. I will share with you tomorrow it's a zip file with specialized agents for going and applying the task-driven principle and the specs-driven principle with the MOSI framework if you want to give it a try. So this is a local thing that you can download the Star repository with it, and then you start giving instructions, and you will see how it works. It's including also it's not like a handbook version of this presentation because it's going more in details on the last part, but it is a handbook. So you will get there as well a PDF. I think it's like almost 100 pages that I wrote about how to master prompt and specs-driven development. So you get all of this. I will send it to the email that you registered on Eventbrite. And you can have a look at the website, and you will see there which part of the capabilities, as I'm calling them, in the spectrum they are covering. So yeah, that's tomorrow. If it's not tomorrow, give me some time. I will do that on Monday, but I will try my best to send it to you, to all of you tomorrow. Any questions? Just to tell you before that I will probably be organizing more webinars like this on some related topics. So if you found it useful, just keep an eye on my LinkedIn profile, and then I will try to make as much noise as I can about it, so you will know. Any questions?
Yeah. I was wondering, you mentioned your code is not your mode, but I think that really depends on how competitive your business is, right? Like Samsung, they leaked some of their semiconductor code. It was a big problem for them.
Yeah. Okay. So in whatever industry where the code is actually, they are even applying intellectual property to it. They are registering it as intellectual property. So in that case, yeah, then those organizations, they need to evaluate whether it's worth to have an AI agent exposed to that code, because you never know. Well, you can follow their privacy statements and whatever, but yeah, you never know if they are changing it tomorrow and then your code is pushed to the cloud.
So you made somewhere this diagram where you say we split it up in multiple components, and you literally said, oh, but when then something changes, you could ask AI to fully rebuild the component. If you would do a complete rebuild of, or like a major improvement on a certain component, would you ask AI to do a full rebuild, or would you ask it to do an iteration on what's already there?
I would try to add an increment to the existing component. They replacing the component, it's more like, I would say, like a last resort action when it's so much spaghetti inside the component that neither you nor the agent can evolve it, right? You say, okay, let's start over again because this has gone too far.
I did have some colleagues that like to generate lots and lots of code. So how does code review have a place in this? Are we going to have an agent that does code review for the other agent, or are we going to have to review 1,000 lines of codes based on the specs provided?
So that's a very good question, because actually, which is really funny, is that you start prompting AI agents to create code, and typically when you are not specifying that you want really simple and let's not do a scope creep and follow these practices, especially if you don't say any instruction, they will create a lot of code. And the more code they create, the more money you are probably paying. But then the funny thing is that there is another company, I won't say the name, but it was on the slide, that they are selling you the service of reviewing the PR with another AI agent, and you pay them as well. So then it's like it's the circular economy where where you are paying for multiple services, and you are paying first the producer, then you are paying the one that is simplifying, and yeah, you can pay for a lot of AI tools, but there are already tools that can review the code quite automatically, I would say. Even reject the review if they see like they are increasing the complexity. You can introduce a few metrics there.
Yeah, I've also added 2 different reviewing agents, and they also review each other's comments and say, "Hey, Copilot is completely bullshit what you just said." Quite interesting.
Yeah, but it's actually quite frustrating. I have to recognize as well, and I agree with you, Thomas, because I needed to write so much prompt engineering around do not build anything that I didn't tell you to build. Try to keep it simple. And it's so counterintuitive because that should be natively built into the AI agent, right? You can only think that if they are not adding this, it's because of some weird purpose, because it's the moment you do that, they start behaving much better. So it's like, okay, maybe there is a goal also on the amount of code that they are writing. But yeah, I hope that will improve. I think the same thing as they are adding features to keep you in the plan stage before going into coding, and that has evolved a lot in the last couple of months. I think that it will also try to create as little code as possible, let's say.
I have one question. You mentioned that as a developer, you also kind of become more of an architect, and that you also start prompting, which is also becomes almost requirements engineering. What is the role for architects or business analysts in the future? How do you imagine the business maybe is going to use AI themselves too? How are we going to, as developers, bridge that gap between the business and...
I think the role names will change, but so there are like certain things. So that's why I talk about capabilities and not role names. I like more talking about capabilities because you are a technical person, but you can do things that typically a product manager would do, or a business analyst. And nobody should care about that as long as there is no gap in the process, right? That's people are doing this thing. Now there is becoming trendy. One name of a role. What is the name? It's like there is something after the full stack developer that is, they gave a name to a role of an engineer. I don't know if that was front facing engineer. No, something like that. That it means like you are thinking about the business as well, and that to me is quite offensive because it's like, come on, what that does mean that the software engineer is not thinking about business. It depends on the person, right? You can be more technical and more like, I need someone to tell me exactly what to build, and that is a risky profile in the times that we are. Or you could be a bit more proactive and saying, hey, I want to analyze how the business maps to technical, and they start doing more these capabilities. But their role names will probably change, but not people.
I have another question, Moises. Maybe a little bit with my with my ex-manager hat on. Like, I don't even know how to ask it exactly, but like, say you've rolled out Claude Code to an entire development department, like 100 people, etc. And then Anthropic goes bankrupt, or they go in a direction that you really don't like, or whatever, or they jack up the prices in some way. Like, how much friction is there to like change that to something else? Like, how much vendor lock-in do you get to?
It's a good question as well. So there is, for example, there is a standard now that many, just to give you a sample of things that are doing. In between these coding agents, at the beginning, there were no standards on how to specify instructions for the coding agents. But then OpenAI, GitHub, and other partners, they created a standard that is called agents.md. That is a file with some very high-level formatting that you can apply, and all the AI agents, no matter the vendor, they should look for this file and then start applying these instructions. Claude Code started with something else. They started with Claude.md. The last time I checked, they are not changing to agents.md, and they are creating features and functionalities that are not aligned with what other people are doing. So we are in still an early stage where different partners are following different ways, but the content of what you are creating, which are the tasks and the instructions unless something really major changes. Because it's natural language, I don't think that the friction will be that high. If you would need to apply a very specific formatting to pass the instructions, then you have a lot of vendor locking. But you can check tomorrow when I'm sharing the instructions. It's just plain English with uppercase where you want to make it very important. You must not do this. You must do this. And then these are things that you can pass from one agent to the other. A different thing is that you adopt a more structured framework like Amazon Keto or something that is driving the entire process. Then if you need to migrate and there are like a specific formatting files or whatever, then you might be in trouble because then you need to migrate all these things to another framework.
Yeah, thanks.
Cool. Any other final question? No? Okay, so yeah, thank you very much for your attention. I hope that you enjoyed it. I will share with you the material tomorrow as well with the recording. If you like it, feel free to recommend it to other people because I will be doing more. So yeah, then I can do more sessions like this. Well, have a nice evening. Thank you for staying with me until that late.